Discussion on sound waves, and this is lecture number. This is lecture 2. And I think in the last lecture we discussed this idea of pressure wave, density wave, and then we saw some relations between the max value of pressure wave and the max value of density wave and the max value of displacement wave. Those things, we made some graphs and we made some conclusions. Good. And last time I used this result that V equal to under root B by rho, and then we made some conclusions. But I told you we will prove that result, so we will do it today. Okay. So let's talk about the speed of a longitudinal wave. Speed of a longitudinal wave. Okay. We will follow the same setup as we have done last time, that you will have a medium of density rho, and we will take a very small element of that medium, a cylindrical element, and study that. Okay. So let's say I have a medium like this. Okay. And then I am studying this cylindrical element of the medium. Let's say this position is x equal to 0, this is x equal to x, and this is delta x. The cross sectional area of this cylinder is S. These things are given. Okay. And let's say this point is A, this point is B. Okay. To find the actual speed of the longitudinal wave, so I have not turned on the source. This is a little element, a cylindrical element of a huge medium, and the medium may contain some kind of gaseous particles, or it could be anything. So let's say it has these particles. Okay. So for finding the speed of the longitudinal wave, I will try to use it. I will try to find it using the Newton's second law. Yes? And what was the Newton's second law? Do you remember? That's F net equal to ma, na? F net equal to ma. Yes? Can you tell me what is the, if the density of the medium is rho, density of medium is rho, then can you tell me what is the mass contained in this cylinder? Rho into S into delta x. Very good. So that's density equal to mass upon volume, and mass equal to density into volume, na? So mass is equal to density, that's rho, and the volume of the cylinder is S into delta x. Does it make sense? If y is the displacement of the particle, then what is the acceleration of the particle? If y is a displacement, then what is the acceleration? Not d. No, not d. Del 2y by del t2 is correct, because y is a function of x and t. So that's much more appropriate that you take the partial derivative. So we found my mass and acceleration. Na? I just need to find my net force acting on this block of this. Yes. And we have some information about pressure. So do you remember I wrote this last time, that final pressure of the medium is P initial plus delta P. And I assume that the P initial is P naught. Do you remember that? Then what is the pressure of the medium as a function of x? That's P naught plus delta P as a function of x. Do you understand? So what will be the pressure here then? The pressure here will be P naught plus delta P as a function of x, that's P of x, and the pressure here will be P of x plus delta x will be P naught plus delta P x plus delta x. Does it make sense? These are the pressures at different values of x. Then what is the net force acting? What is the relation between pressure difference and net force? अरे force is equal to pressure upon area ना, the pressure will be equal to force into area, and what is the net pressure acting? That's the difference in the pressures ना. Yes, so net force is P of x plus delta x minus P of x into what is the area? S, and this is equal to MA. What is M? Rho S delta x into del 2 y by del T2. Is there any problem till here? Whatever I have done, I can cancel the S, and let's take the delta x on the other side, and then I get P of x plus delta x minus P of x divided by delta x, which is equal to rho del 2 y by del T2. सही लिखा है ना मैंने? Hopefully this is correct. Am I missing a negative sign somewhere? It's all correct, na? Seems correct to me, but there must be a negative sign somewhere. ठीक है, let's go forward. In the limit that this, if I take this cylinder to be very, very small, then what is the length of the cylinder tending towards? Limit delta x tends to 0. What does this become? What does this become? That differentiation. But what differentiation? Partial. Why? Because pressure also depends on time, na? I have not written it, but obviously it does. So this will become partial v by partial x, which is equal to rho del 2 y by del T2. There must be a negative sign. I am putting it right now. Abhi rehne do, but I will try to justify it later. There must be a negative sign. Okay, I am missing it. Anyways, del p by del x, we found it to be this. Any problems still here? What was the definition of bulk modulus? Do you remember? Definition of bulk modulus? बताओ volume. It should be this. है ना? ये stress upon strain ही है ना? Volume stress divided by volume strain. So you will get minus V dP by dV. So I also found it to be minus V del y by del x, by the way. Please check. I found this result yesterday, na? You remember this? Then what is, this is B. Okay. No. This is dP is, what was the result that I found in terms of del y by del x? Can you tell me that? I found a result yesterday.
Delta P equal to minus B.
अच्छा, delta P equal to
minus B delta x by delta V.
minus P B delta x by delta V.
And when delta x tends to 0,
What are you saying? Should be, I think it should be something like dV is equal to minus B dV by V, and then I found it to be what?
minus B dx by dV.
Minus B dx by dV और del y by del x. del y by del x निकाला होगा शायद से. Please check ये सही है क्या? Did I find? I think I found yesterday delta. Please check, is it correct? It's correct, right? I think I wrote as yesterday as well, this is delta and delta. There's no problem in it. Those are changes. You can take delta or d right now. So this is delta P by delta V, and this I found to be delta V. Is it correct? If I divide by delta x, and in the limit delta x tends to 0, what will the left hand side become? Imagine divide by delta x and take limit delta x tends to 0. What will the left hand side become? What do you think? That will become del p by del x, na? So it's as good as differentiating with respect to x. So I will imagine that I am differentiating with respect to x, and this will be minus b del 2y by del x2. Does it make sense? Acha, I wrote del p, I did not write del of delta p. Actually, more appropriately, I should write del of delta p. But del of p and del of delta p are same. Why? Because the only thing that is separating them is this. And when you differentiate p naught, that's 0. So it doesn't matter. Does it make sense? So I wrote del p by del x. I found one more equation of del p by del x. But since the LHS of both the equations are same, that means the RHS should be same as well. Then if I compare, then what will I get? Comparing 1 and 2 gives rho del 2 y by del t2, which is equal to b del 2 y by del x2. Acha, let me take this rho and put it here. Have you seen this kind of equation before? What does this equation resemble? No. यहाँ पे माइनस रो लिखो, यहाँ पे माइनस बी लिखो तो ओके. बताओ ये what does it resemble? Yes, condition of a valid wave function. That was the wave equation. And what was the wave equation? Do you remember? It was del 2y by del t2 del 2y by del x2, where what was the v? That was the speed of the wave. And if you compare now, what should the speed of the wave come out to be? This is the result that I used earlier, na? And this is what you find, that the speed of a longitudinal wave is under root b by rho. Please understand this. I am talking very generally right now. I said the speed of a longitudinal wave. I did not say seismic wave. I did not say earthquake or maybe sound wave. Those are all also longitudinal waves. But I did not take any example. I am talking in general. In general, the speed of a longitudinal wave is this. Longitudinal wave in a medium of density rho. Is it okay? Are you done writing, or do you want to write from the start? Huh? Do you want to write from the start? करो. ये माइनस साइन कहाँ से आ रहा है मैं नेक्स्ट टाइम बता दूंगा. आई एम मिसिंग समथिंग हियर. देयर शुड बी अ माइनस साइन. Is it understood to everyone? Yes? Don't sit around. करो. करते जाओ. If you have understood it, you can even do it yourself. Everyone has made the diagram? Yes.
But I get it. Suppose if these two become as part.
What does this look like? If I take the limit delta x tends to 0. This is, imagine it to be delta p. What is this equal to?
Del p by
dp by dx. dp by dx. But the thing is that p is a function of many variables. So the appropriate derivative will be del p by del x.
we are considering this whole thing to be delta p.
There's a change in pressure na? Between these 2 points. Is it written? If it's written, then tell me. लिखो जल्दी जल्दी. Is it done? Good. Now looking at this formula, let me ask you this, कि the velocity of a longitudinal wave, it looks directly from the formula, it looks as if it depends on the bulk modulus, under root of the bulk modulus. Let me ask you this then, what does the bulk modulus depend on in terms of thermodynamics? What does the bulk modulus depends on? And keep in mind some thermodynamics. What does it depend on? सोचो. Let me give you a hint. Go back to the definition of bulk modulus. And then give me an answer. From that, can you conclude something in terms of thermodynamics? What is that pressure by volume? Yes? Any answers? What isothermal? So only that. What do you mean by isothermal isobaric? What does it depend on? It depends on the isothermal process or isobaric process specifically. What is the bulk modulus ka definition? Minus V dP by dV. I have written this now. Tell me now. What is that? क्या ये तुम लोग रैंडमली कोई भी प्रोसेस का नाम क्या ले रहे हो? Array idiots. What is that dp by dv represent? It represents the slope of P versus V diagram. This represents slope of PV diagram. And don't relax now, I'm going to ask more. What does the slope of PV diagram depend on then? Temperature. Number of moles. What does the slope of PV diagram depend? Huh? कुछ भी any time बोलता है बच्चा. It depends on the process that you are talking about. If you take an isothermal process, the PV diagram will be different and the slope of the curve will be different. If you take an adiabatic process, the slope of the curve will be different. If you take an isobaric process, its slope will be different. So the slope keeps on changing if you talk about different processes. Yes or no? Yes or no? So the slope depends on this process that we are talking about. So depends on the thermodynamic process. Thermodynamic process. That means what does the bulk modulus depend on? It depends on the process through which the whole thing is going. Does it make sense to you? Let me talk about, just for fun, let's talk about isothermal process. For isothermal process, and let's say I'm taking for ideal gas. What is dP by dV? What is dP by dV for ideal gas isothermal process? Find it and tell me. Everyone should know this. कुछ भी. What is dP by dV? The slope of the graph. वो जो तुम बोल रहे हो ना बेटा, वो एरिया अंडर ग्राफ है, वो स्लोप नहीं है. What is the slope of this process? बताओ. चलो, let me help you with this one.
Minus nRT by V.
Can you write it in terms of P and V? Minus P by V is correct. And the way in which you do it is you follow the equation of state. And what is the equation of state for an ideal gas? That's PV equal to nRT. But since you are talking about isothermal process, you take the temperature to be constant. And then what do you get? PV is a constant. If PV is a constant, then let's differentiate it. D of PV, that's 0. And that's VdP plus PdV. That's the product rule. And then what do you get the dP by dV to be? Minus P by V. Yes, this is my slope of the graph. Then what my bulk modulus will be? The bulk modulus is given a new name now. It's not the, it's called the isothermal bulk modulus, BT. And what is BT equal to? That's minus V. dP by dV is minus P by V. So that's P. Isothermal bulk modulus. And that's why the bulk modulus is equal to the pressure of the medium when we talk about isothermal processes. Now just for fun, tell me for adiabatic process. Find me what is dP by dV for an adiabatic process. Do it. What is dp by dv for adiabatic process? Come on, don't take इतना टाइम, तो बहुत आसानी से आ जाना चाहिए. It will be minus p by v. Incorrect. क्या should I do it myself? Gamma into p by v, there's a negative sign, so I should find minus gamma p by v. And how will I find it? What do you write here? You write the equation of state. And what is the equation of state for an adiabatic process? PV power gamma is a constant. Yes, this is the equation of state. Then you differentiate it, and then what do you get? D of p v raised to gamma is a constant, that's 0. So that means you will get p and then apply the derivative. That's gamma v raised to gamma minus 1 dv, the chain, plus v raised to gamma dp. Yes? And then I think I can take v raised to gamma common, and then I will get something like gamma p by v dv plus dp. This is equal to 0. Either this is 0 or that bracket is 0. So obviously the bracket is 0. And then what do you get? You will get dp by dv to be minus gamma p by v. This is my dp by dv. Then what will my bulk modulus be called this time? This is the adiabatic bulk modulus now. And what is that equal to? So BA is minus v, the slope of the curve, and the slope is minus gamma p by v, and this is gamma p. So adiabatic bulk modulus is gamma times p. And if you want to generalize it to any kind of process, PV raised to R, what is that process called? PV raised to some R या फिर M. That's polytropic. And can you guess what will be B for polytropic? Just multiply with that number here. Instead of gamma, write R या M, whatever. And then it will follow that M equal to 1 pe you will get isothermal. M equal to gamma pe you will get this. Very simple. Why did we do all of this? Because now I want to find the speed of sound. And if you remember, the speed of a longitudinal wave depends on the bulk modulus. And now let me ask you this. When a sound propagates through air, then what process it follows? What thermodynamic process it follows? Adiabatic, he says. Any other answers? Why adiabatic? Why adiabatic? I have written this in the class as well. ये मैं लिख के दिया था, पूरा explain भी किया था तब. Sound propagation through air, what kind of thermodynamic process is it? If you are not sure, then let's try to do it for everything. Let's assume isobaric process. Isobaric process में what's dp? बताओ what is dp for isobaric process? रुक जाओ. Let's do for all of them. What is dp for isobaric process? मैं 4 बार पूछ चुका हूँ अभी तक. 0 होएगा ना? 0. Then what will be the bulk modulus equal to? 0. Then the sound wave का speed कितना होएगा फिर? 0. Does it make sense? No. Isobaric नहीं है ये. Isochoric बताओ. Isochoric में what is dv? 0. Then what is bulk modulus? Infinity. Then what is speed of sound? infinity. Does this make sense? तो isobaric भी नहीं है, isochoric भी नहीं है. Let's assume isothermal. If we assuming propagation of sound through a medium of density rho to B. Let's assume isothermal. If I assume isothermal, then what is the bulk modulus that we found? What is the bulk modulus that we found? That's P, na? Then what will the speed of sound will come out to be? B by rho. That's under root P by rho. And do you remember what is this result called? This is the Newton's result. Newton found this thing and he estimated the speed of sound and he got somewhere around 280 meter per second. But do you know what is the speed of sound? It's somewhere around 330, 340. So you are off by 50 or 60. Then is this result correct? No. So that's incorrect obviously. So can the process be isothermal then? No, even this is incorrect. This is Newton's result. Then what is it? It's adiabatic. But why? Can somebody tell me physically why? Why sound ka propagation through air is an adiabatic process?
Because in adiabatic process it can move faster than in isothermal.
All fast processes are adiabatic. All slow processes are considered to be isothermal. I have discussed this probably in the class. So speed of sound or sound propagating through air is a fast process. Okay? So it's this is wrong. Then if I assume it to be adiabatic, then what is B? That's BA gamma P. Then what is V? This is BT by rho. That's gamma P by rho. Yes, if you remember, I have given all these results in wave motion at the end of wave motion. What is that gamma called?
CP by CV.
That's gamma equal to Cp by Cv, and it's also called the Laplace correction factor. Maybe after 100 or 200 years, I don't remember exactly, Laplace came and then he assumed that no, sound propagation should be an adiabatic process. And then if you follow this result, you'll get exact correct answers. Okay? So this is called the Laplace's correction factor. Is it okay? So that is the speed of sound. Please understand this, that we are specializing now. If you remember, the initial result was quite general, under root B by rho. That was for a longitudinal wave. It did not care about what process it is or anything like that. What is this result? This is the speed of sound specifically, and when you consider that the process is adiabatic, only then. So don't mix up the results. Don't apply this result for a longitudinal wave. Okay? So this is speed of sound in a medium of density rho. Let's go a little further. Can you already remember that this can also be written as gamma RT by M? It can be. कर सकते हो खुद से? For that, what do you have to assume? You have to assume something. For finding gamma RT by M, you have to assume that the whole medium is made up of ideal gas. Ideal gas, only then you can follow it. So, assuming medium is filled with ideal gas, then what do you get? You will get PV equal to nRT, but N, the number of moles, can be written as mass by molar mass, na? Yes? ये करो, खुद से करो, मेरे ऊपर डिपेंडेंट मत रहो. होपफुली ये कर सकते हो ना तुम लोग तो. And what is that capital M? That's the molar mass. Then what will my speed of sound become now? That will be gamma by rho P. P is rho RT by M. Rho cancels. So now please understand, all these results are mutually exclusive in a sense. The first one is quite general, you can apply it anywhere. And the second one, you can apply it for sound waves for any medium. The third result that we got, only for ideal gases. Don't apply it for any other medium. Okay? So this is the speed of sound only for ideal gases. Is it okay? Don't mix up the results, please. Scroll. ऊपर का देखना है. From where? पूरा. करो, लिखो. जाओ. Don't talk and write quietly. जाओ. बी लिख दो, BA लिख दो, चलेगा, क्योंकि इधर
मतलब आपने BD लिखा तो कंफ्यूज है.
BT तो ऊपर है. इधर
नहीं सर, आपने इधर लिखा.
मैंने BT लिख दिया है क्या उधर? कहाँ BT लिख दिया? अरे यार, ये BT नहीं है, BA है ये. ठीक है, लिखो जल्दी जल्दी. Is it okay if I minimize a little bit? Are you able to see, backbenchers? क्या है? जाओ जाओ. You sit there. You go and sit here. अच्छा ठीक है, जाओ. Is it written? हाथ चलाओ जल्दी जल्दी. How many of you are still writing? 2-3 people only. चलो चलो जल्दी हाथ चलाओ. Done? Yes. So we have discussed all the velocities that I told you earlier, and let's try to see what is the effect of different things on the velocity of speed. So effect of temperature, pressure and humidity on Vs. Okay. So for an ideal gas, at least, what is the expression that we got? Gamma RT by M, na? And so let's talk about effect of temperature. For ideal gas, what is the relation between Vs and T? This Vs is proportional to root T, na? From this? Yes? Then what can we write? Vs2 by Vs1 is root T2 by T1, right? Yes? Now, the way in which, so we are comparing two values of the speed of sound, na? We can compare them, but it's much more better if we get an absolute value. And how to do that? You define a reference. And let's say ki at some temperature we know some value of speed. And let's say ki we know, you should remember this, that speed of sound Vs is equal to कितना है 332 meter per second. Let's call it V0 at 0 degrees Celsius. Acha, those temperatures are calculated in kelvins, huh? Please remember that. And let's say कि I have given you this experimentally found result. You know this value, ठीक है? Then can you find the velocity at any temperature? You can find it, na? You can compare. You can do it like this: the velocity of sound divided by velocity of sound at 0 degree Kelvin, 0 degree Celsius. That's T divided by 0 degree Celsius. That's 273 Kelvin, na? Is it okay? Then this can equally be written as Vs, which is equal to V0 root T divided by 273. So can you see that we can find the velocity of the sound at any temperature T? How did we do that? By fixing some value of V0. By taking some reference. Using that reference, we are getting all those values. Good. Achha, I can write that capital T in terms of this as well. V0 is equal to 273 plus small t. What is that small t calculated in?
Celsius.
That's calculated in degrees Celsius, na? This was calculated in Kelvin, that's calculated in degrees Celsius. So I can equally write this result to be, achha, this I should highlight this, calculated in degrees Celsius. Please remember that. Then this can equally be written as Vs, which is equal to V0 plus 1 plus T by 273, the whole power half. Is it okay? Do you know binomial expansion? What is binomial expansion? 1 plus x the whole power n is what? approximately 1 plus nx, na? Yes? Then let's say 273 is a huge value, and this small t we will calculate in degrees, those will be smaller as compared to 273. Acha, when can you apply this condition? Do you remember? When x is very small as compared to 1. So let's say the small t is much more smaller than 273 and the whole number is going to be smaller than 1. Then you can apply the binomial, and then what do you get the result to be? 1 plus वो हाफ नीचे आया तो ये मल्टीप्लाई हुआ कितना हो गया फिर 546 t by 546, and this is my velocity of sound. You can equally write it in a slightly different manner कि v naught you write it as 332, and then this will become 1 plus t by 546. This will come out to be equal to 332 plus 0.61 t. ठीक है? These are the velocity of sound. Now please remember this. अच्छा, let me make the comment and then let me say कि for every rise in degree Celsius, your speed of sound increases by 0.61 meter per second. है ना? If t equal to 1, then your this increases 0.61. If t equal to 2, then twice of that. So for every rise in degree Celsius, you keep on increasing the temperature, your speed of sound keeps on increasing. Does it make sense? It's a straight line. It follows a straight line equation. Now let me give you the precaution. Everything that I did from there till here, these are all approximations, please remember. What kind of approximation did I use here? Binomial. The initial start that I approximated was ideal gas. So all of these can't be used everywhere. Remember that. If you want to be quite general, then you can always go back to this result. This result. Apply this if you want to be general. But if you remember everything precisely, then you can apply all the formulas at your will. So बहुत carefully करना. Can you tell me if your T is somewhere around 400 degrees Celsius? Then can you apply this equation? Can you apply this equation with if T equal to 400 degrees? No. Why? Because this is not less than 1. You can't binomial approximate and get that. Then you have to rely on this equation. या फिर that equation. है ना? So understand when to use what. Don't blindly apply anything everywhere. ठीक है? Good. This is the effect of temperature. We found that as temperature increases, the speed of sound increases. For every rise in degree Celsius, there is a rise by 0.61 meter per second approximately. Okay. I also wrote another effect, effect of pressure. If I take for constant temperature, what is RT by M then? RT by M is equal to P by rho, and this should be a constant. Yes or no? If you take constant temperature, then this value is a constant, then this ratio has to be constant as well, since it's equal for an ideal gas. Yes. Then what was your velocity? Your velocity was under root gamma P by rho. But then this will even be constant even if there is a change in pressure. Do you understand? You may look at this equation and then you say your velocity is proportional to root P. And if there is a change in pressure, there will be a change in the velocity of sound. And you will be correct in the cases where temperature is not constant. If the temperature is constant, then even if there is a pressure change, there will be a corresponding change in density. Do you know why? Because you remember the variation in pressure, we found it to be BAK sine something, and then what was delta rho? Rho AK sine something. They are in phase. They are in phase. Whatever variations occur here, there will be a variation occurring here as well. So as pressure in the medium changes, the density naturally changes, and they change in such a way that the ratio remains a constant for a constant temperature. ठीक है? So velocity is not proportional to root p for constant temperature. So it's a constant. Does not change. ये 1/2 इधर लगाओ. ये है ना 1 + nx, n को इधर ले आओ. समझ आ रहा है? ये करके दिखाऊं? अरे बेटे, ये कहीं की बात कहीं पर पूछने लगता है. ठीक है, छोड़ो, ये छोड़ो. आर यू अंडरस्टैंडिंग दिस सेकेंड प्रेशर वाला? Okay, this is the effect of pressure. Have you written till here? Let me complete it and then you write. Let's talk about the effect of humidity. So humidity meaning moisture in air, na? So what do you think? Density of a moist air will be greater than density of dry air, or will it be lesser, or will it be equal? Think and then tell me. Rho moist and rho dry क्या है? What is correct? Are you sure with that?
Because for the same given volume, mass is more for the moist.
हाँ बोलो you. Yeah. हाँ. But then I am asking, what is the correct one? Think physically and then you tell me whether rho moist is greater than rho dry or less than or equal to. If you have a moist air, then is there a possibility of condensation? There is a possibility of condensation. Na? Then the number of particles, since the condensation occurs, they will settle down on the surface. Then what about the number of particles in the medium? Will they decrease or increase? Decrease. Then what is density? Now, mass divided by volume. Na? Did the mass decrease from the medium? Then what will happen to density? Decrease. So rho of moist is less than rho of dry. And if we assume that the gamma is same for both of them,
Once all the moisture settled down.
not all the moisture settle down. So
The condensation occurs, then it's no longer moisture.
no longer moisture. अरे बेटे, just because some of the particle got condensed and settled down doesn't mean कि all of them will settle down.
Then would mass of moist air is more than mass of dry air, right?
Yes, but then they also get, you also have to think further, na? They will follow this condensation process, they will settle down and हो गया. Does it make sense to you? नहीं?
We are talking about the process after condensation.
I am talking the whole thing, after the whole thing.
So if we look at only one time period, right? So
नहीं.
what if in that same period dry air also converts into moist?
Dry, अरे कुछ भी बोलता है idiot. I am going to assume that gamma of moist is approximately equal to gamma of dry. That's not true either. It's actually one of them is greater than the other, but we will all in all approximate it to be the same. and you should check it why the gamma will differ. But anyways, then you can say that the velocity of sound in moist air is a little greater than velocity of sound in dry air. ठीक है? So these are the results that you should know, and copy कर लो, and then we can do some problems. Are you done writing? इतना हो गया फर्स्ट पार्ट. क्या स्वाइप और ऊपर? जाओ जाओ. Don't talk. Is it done? Done? So I'm done with the theory that I wanted to discuss today. We can do some problems now. Okay? attempt the question. I will start in 3-4 minutes, okay? क्या? I don't know. You think? Zero point into 10 power what? 0.09 10 power 5. For what question? Incorrect. Should I start with the question? Hmm? 33 एक बार इनकरेक्ट वो भी इतना सिंपल तो कैलकुलेशन है इनकरेक्ट इनकरेक्ट इतना वाह इतना स्लो है हाँ बोलो 10 सेंटीमीटर पर सेकेंड वाह और ज़्यादा स्लो हो गया बच्चा नहीं इतना स्लो नहीं होता बेटा ठीक है आई एम डूइंग इट ये 4-1 है 4-4-1 चलो ठीक है okay so they are asking about longitudinal waves they did not specify any sound waves or anything so don't use gamma p by rho that's just wrong ठीक है you have to use b by rho under root b by rho that is the formula So that's why I told you be very mindful when you do apply the formulas, है ना. तो that's under root b by rho. एंड हो गया क्वेश्चन, कुछ है ही नहीं. सब्सटीट्यूट 1.41 10 पावर 5 डिवाइडेड बाय 1.43. यस. अब देखो अप्रोक्सीमेशन, ठीक है. ये और ये तो कट गया, ठीक है. तो ये हो जाएगा अप्रोक्सीमेटली अंडर रूट 10 इंटू 10 पावर 2. अब रूट 10 कैसे निकाले? इसको मैं लिख देता हूँ ऐसा, देखो. हाँ, अप्रोक्सीमेटली रूट पाई स्क्वायर. पाई स्क्वायर की वैल्यू कितनी होती है? 9.98 ऐसा कुछ तो होता है शायद, है ना. तो ये हो जाएगा 3.14. तो कितना आंसर आ रहा है? एग्जैक्ट आंसर लाया हूं मैं, यही आंसर. समझे क्या? पाई मैंने ले आया. पाई का स्क्वायर इज अप्रोक्सीमेटली 10. समझे क्या? नाउ टेल मी द बी पार्ट. चलो बी पार्ट करो, वो तो और ज़्यादा सिंपल है. हाँ, आ गया आंसर. इतना काट दिया ना ऊपर ने. 17 18 को एक ही मान लिया. ठीक है, चल जाएगा. यानी चलेगा नहीं, रॉन्ग ही है, लेकिन फिर भी नो. 10 पावर 3 people are getting, I will get the same answer, but that's correct नहीं है, that's incorrect. The actual answer is 970. ये 1000 ला रहा है, 30 से ऑफ दे रहा है. एक्सेप्टेबल नहीं है. देखो अप्रोक्सीमेशन करो तो अच्छे से अप्रोक्सीमेशन करो, गंदा अप्रोक्सीमेशन नहीं करना है. अभी मैं तुम लोग को दो आंसर लाके दिखाऊंगा जो दो अलग अप्रोक्सीमेशन से करेंगे हम, और फिर भी आंसर सही आएगा. एक सही आएगा, एक गंदा आएगा. चलो करते हैं बी वाला पार्ट. अगर एग्जैक्ट करोगे तो अच्छा आंसर आएगा. एग्जैक्ट करो, कितना आ रहा है? हाँ तो बोलो, रूट का आंसर बताओ. What is the bulk modulus here? अभी पहले मैं गंदे तरीके से करूंगा और उसके बाद फिर हम अच्छे तरीके से करेंगे, ठीक है. तो अब मैं इसको, ये कट गया, ये तो ये 10 सा अप्रोक्सीमेटली, ठीक है. तो ये हो जाएगा एंड द आंसर इज, यानी कि 1000. लेकिन ये तो गलत है, ये गलत है. अब अच्छे से करेंगे, ठीक है. तो एक है 17 इंटू 10 पावर 6 और ये है 18 इंटू 10 पावर -2, है ना. इसको करते हैं 17 इंटू डिवाइड बाई 18. 18 को 2 इंटू 9 लिख देता हूँ, इंटू 10 पावर 2 ना. यस. अब वो रूट 2 की तो वैल्यू पता है. रूट ऑफ 9 3 होता है. रूट ऑफ 17 कितना होगा? 4.1 4.2 ऐसा कुछ. तो बोलो 4.1 का कितना आता है? .2 ले लूँ क्या? 4.1 चल जाएगा. चलो 4.1 ले लेते हैं. तो दिस इज अप्रॉक्सीमेटली, ये भी एक अप्रॉक्सीमेशन, बट दिस इज मच मोर बेटर. 4.1 डिवाइड बाय 1.414 इंटू 3. अब ये करो, आंसर आ जाएगा पक्का. हाँ, 978.28. वेरी गुड. दिस इज स्टिल ऑफ, अ लिटिल ऑफ. द आंसर इज 972. बट ठीक है, चल जाएगा. दिस इज मच मोर एक्सेप्टेबल आई थिंक. सी, so do the approximation but do it correctly. यस, ऐसे नहीं काटते बेटा, ये इसने किया था, मैं दिखा रहा था, ये ऐसे नहीं करते, समझे? द फर्स्ट वॉज this one. What you are doing basically, you are doing this, and then you are saying this is vanza, है ना? That's it's totally different. That's totally different.
There is 100 difference, sir.
No, that's totally different.
1400 and
कुछ भी, that's 141 divided by 143, that's approximately 1. ठीक है, समझ आ रहा है? तो अच्छे से अप्रोक्सीमेशन करो, नहीं तो एग्जैक्ट लाओ, मुझे कोई प्रॉब्लम नहीं है इफ़ यू डू इट एग्जैक्ट. ठीक है, लेट्स डू अ सेकंड क्वेश्चन देन. हाँ विरूपाका, डिड यू डू इट एग्जैक्ट? क्यों? Anybody who did it exactly? थोड़ा सा, हाँ एग्जैक्टली आया, कितना आ रहा है? अच्छा करते रहो. इट्स मच मोर बेटर इफ द ऑप्शंस आर वेरी वाइड. हाँ, ऐसा कोई 800 मीटर पर सेकेंड दिया है, कोई 1500 मीटर पर सेकेंड दिया है, देन द मार्जिन ऑफ एरर इज़ नॉट दैट मच. तो अगर 1500 आ रहा है या फिर 1570 आ रहा है, अप्रॉक्सीमेट सेम ही हो जाएगा. तो वो कॉम्पिटिटिव एग्जाम्स में अगर ऑप्शंस आर वेरी क्लोज तब तो मुश्किल हो जाएगा. अगर ऐसे दिया है 9 और उसके बाद 10, नॉट इवन 9.5, तो फिर 9.5 में यू कैंट मेक अ कंक्लूजन ना कुछ, तो थोड़ा प्रॉब्लमेटिक हो जाएगा. अटेम्प्ट. हरितेक आया, चल रहा है अभी प्रोसेस, मुश्किल है, कोई बात नहीं, करना चाहिए. बहुत हंसता क्या है? अटेम्प्ट. Hey, this is not 978. This is something like 966.5 to be more precise. And the actual answer is 972.
Actual answer for part A.
314. I got it exact. आंसर लाने का भी एक आर्ट होता है बेटा. the root of 17 is 4.12 actually. 1 2 3 ऐसा कुछ तो, and then you will get 979.1. ये रूट 17 निकालना, ठीक है. 4.123 होता है. Anyways, attempt the second question. Come on, this is much more simpler. This is simple division. बोल 100 कैसे कुछ भी बोलता है बेटा. वो केल्विन में किया ना उसे. अच्छा केल्विन में ही नहीं किया. हाँ, if nothing is mentioned then assume. Do you want this as a homework? ठीक है. 3 नहीं आने वाला है. Should I do it or should I give it as a homework? Homework? अभी करूँ? How many in favor of I should do it right now? How many in favor of you want it as a homework? ठीक है छोड़ो, मैं कर देता हूँ अभी. No. In India majority wins बेटा. गामा आर टी बाई एम ना, तो वी ऑफ ऑक्सीजन वी ऑफ हाइड्रोजन गामा ओ आर टी ओ बाई एम ओ एंड टेक द स्क्वायर. लेट्स टेक द स्क्वायर. देन यू विल गेट समथिंग लाइक गामा एच आर टी एच बाई एम एच. नाउ गामा ओ एंड गामा एच, what are they? Are they same or not? Hydrogen and oxygen both are diatomic gases, so they will both have the same gamma. है ना? Then what is TH? So TH will be equal to TO MH by MO. And what are these masses? They are molar masses. So TO कितना है? 100 डिग्री, तो फिर केल्विन में कितना आएगा? 373. तो ये 373. अब मोलार मास ऑफ हाइड्रोजन कितना है और मोलार मास ऑफ ऑक्सीजन 16. तो बस 16 से डिवाइड कर दो बेसिकली, और इसका आंसर बताओ आप 16 से डिवाइड करके. ये कुछ 23.31 आएगा. ये चेक कर लेना तुम लोग, ठीक है. So I am not teaching anything more than this for today. When you are done, you can take the break. ये बंद कर दो ये.